Okay, we have homework 4, part B. The first question is acetone and methanol liquid are vaporized by a stream of pure nitrogen through a 0.24 meter long Stefan tube. The vapor composition at the liquid vapor interface is 0.319 and 0.528 respectively for acetone and methanol. Total pressure at 99.4 kilopascals and maintained at 328.5 throughout. If Stefan-Maxwell diffusion coefficients are D12, D13, and D23, they're respectively solve for rate of evaporation of acetone and methanol using Euler method with Excel and Excel solver. So before we even get into Excel and Excel solver, we first need to find out what equations we need to add into our Excel solver. So we're going to start out like around half of part 1 on my iPad, and then we'll switch to Excel. So I just wrote down basically what this chunk of text up here says, but just down here. So we have length of our Stefan tube, we have corresponding numbers. This already should be 3. I already messed up something. So our acetone 1, methanol 2, nitrogen 3, and we know our acetone and nitrogen is 0.319, which we're going to call Y1. We know our methanol and nitrogen is 0.528, which we're going to call Y2, and then that doesn't equal 1, so we know that our other two compositions is going to have to be 0.153, which is going to be our Y3. And then we have our pressure here to the right. We have our diffusion constants or coefficients as it's set up there. And then I just added this Stefan-Maxwell equation because we are going to be using that for only 2 components because we only need to do 2. And I've decided to do acetone and methanol just because they're the first 2. All good. Okay, cool. So what we're going to do first is we're going to do our acetone and methanol Stefan-Maxwell. So we can start with our acetone, I guess. So let's start with acetone. So we're going to get, basically we're just going to copy exactly what's up here, but for acetone it shouldn't be too bad. So just copy everything, and then, okay, so we're going to have, we don't need the summation, but we do need our y1 n2 minus y2 n1 over our concentration times d, and then I and j is 1 and 2. Easy enough. And then we need our other part, so our summation. So we just need our 3 now, because acetone is our 1, so we need our 3. So we're going to have y1 n3 minus y3 n1. And then that will be over the same thing, but with 3 instead. Okay, seems easy enough. And then all we need to remember is that we got to multiply by our length or our Stefan tube. So once we do that, we're just going to get, so everything on the right is going to stay the same, I think. So we're just going to have dyi over d, because we're going to have to multiply by dz over d, and then we'll get is equal to our length, which I don't even know if we'll use our length, but there we are. We'll put it there. And then I'm just copying everything over quick. It's going to look really messy, but if later when I'm using it for Excel, I can just look off the right side, because I don't think we're going to need length, but it's good to have it here for purposes. So that's our acetone done. And now all we need to do is our methanol. So we're going to do our methanol, which is going to be the exact same thing, basically. Well, this will be 2, but... And then we're just going to start with Y2 and N1 instead of the other way around. 2, 1 plus Y2 and 3, Y3 and 2 over CD2, 3. And then I'm not going to write it, but it would just be this times our length. And then instead of that, we'll have our dy2 over. Okay, that's kind of messy, but it works. I'll just separate this so it's easier to see. Okay, looks good. So, the last thing we need to do, I just remembered, the last thing we need to do is our approximation, or our guess cell that we're going to need fork cell in order to run Solar. So we're going to need, what we're going to do is solve for N2. So, we know that the guess cell that we want is, going to be our concentration, I think, times one of our D's, right? Yeah, over the length. And we know C is going to be, so yeah, we're going to have to separate it. So we're going to get 100 times 10 to the third times D12, which is going to be 10 to the negative fifth, over, and then our length, which is 10, well, our length times the rest of our concentration. And then we know our Stefan tube's only 2 meters, right? Yeah, well, 0.24, I guess. I'll be back. Okay, I just did the math quick, and it's 0.0016 repeating, or 1 over 600. So, so yeah, that's what we're going to use for our guess cell. I'm going to set up the rest of the Excel file, and then I'll be back for the rest of part 1 and the explanation of 2. Okay, I think we're good. Okay, that took a while to set up. So I just set up the Excel a little bit. Here we have our Y1, Y2, and Y3 that I showed in the earlier part how to explain. We have our D, our coefficients that were given to us with unit conversions. We have our other given stuff with unit conversions if needed. The only thing that wasn't given is the C, which we did use in part to find our guess values down here, but we did that by doing our B10 divided by B11 times B12 cells, which is just our pressure divided by our temperature times our value. And then finally, here are our guess cells. We just have a negative and positive one. And then we have our D and our DZ, which our D is our length for our tube, and DZ is our length divided by 1,000, because we're going to do a step counter with 1,000 steps. So that looks good. I think we need to change these into formulas still, which you can do by going to formulas, and then I believe create from selection, left column, okay. I think that's all you have to do. I think I did that right. I'll check when I'm doing formulas later, and if they don't work, then I'll have to cut and figure out what I did wrong. But next up, what we're going to do is we're just going to do next to our Z, we're going to have our Y1, our Y2, our Y3, and then in our I and J columns, we're going to have our dy1 divided by dn, and then our dy2 divided by our dn. Looks good. Sorry. And then the next thing that we're going to do is, oh yeah, we just gotta copy these over quick. Or I guess that we can, well, let's do this first. So our counter we're gonna have to do is going to be our value, so equals to this cell, so the cell adjacent to it, multiplied by our length, dz. So we get 0 there, and then we can copy this down, and it should go all the way to our total length. Make sure before I mess it up. Yep, okay, so it goes all the way to our 0.4, and that makes, we did do the formulas right because it worked. And then our y1 we can just do is equal to b1, oops, I always do that in Excel, equal to our y2, hopefully this doesn't screw stuff up later too. Okay, so there we go, we have our first thing set up. So now we can get started with our dy1 over dn. I just have here in my Outlook, I have what we just did on the iPad. So we're going to need to copy this over, basically, or this over. We don't really need to worry about length here because it doesn't matter later. So we're just going to do these equations, but in Excel using what we know. So for y1, it's gonna be equal to, I have it written down already just because it's gonna be easier. So we're gonna have our f2, so our y1, we're gonna need brackets, hold on. And then it's gonna be multiplied by our n1 value, so we can just use n1, and then subtracted by our our g2 value, and then that's going to be multiplied by n1, and then divided by our concentration times our d value for 1 to 2, and then that's going to be, we're going to add our y2, or y3, sorry, y3 here, our negative y3 multiplied by our n1. Again, this is exactly what we did in the first part. I'm just have it written down because it's kind of confusing, going like this every 2 seconds. That will be multiplied by our c value times our coefficient 13. Okay, we'll see if that's right because I don't necessarily know if that's correct right now. And then we can do our second part, which I also have written down. It's just the same exact thing. I'm gonna actually let's not copy that over. That sounds like a bad idea. So we're gonna have our g2 multiplied by n1 dot minus f2 times n2 dot divided by c dot multiplied by our 12 coefficient plus our negative y3 again, oops, this time times our n2, and then divided by our concentration times our 13. Okay, that looks good, and then simply our y3 is just going to be 1 minus these two cells. Which is 9.5. Something's telling me this is off because I feel like this shouldn't be negative, but I don't... Oh. These are in the wrong... These are not in the right cells. I just now realized that. Oh no, don't make me retype it. That's why I got confused. Well, that is y3, but I can also okay, I think I know what's wrong here. It's gonna be... Why did these change? Fi1? F2... Sorry, I gotta change these quick again. I don't know why they changed. Okay, let's see if that works. Okay, that seemed to work. Okay. I don't know what happened in the other one, so I'm gonna have to retype it out. Okay, sorry for the noise. Hopefully that's correct. Okay, well, we'll check now in when I cut, and I'll check in a little bit, but to continue our y1, y2, y3 cells, we're gonna have our y1 up here, and then that's gonna be added to our dy1, whatever the corresponding value is. Excuse me. And that's going to be divided by, or sorry, that's going to be multiplied by our dz value down here. So that's how we get our next one, and that seems, I don't know if that's correct or not. Again. And then our y2 is going to be the same exact thing here, but instead of what? Okay, wait. What is going on? Okay. I'm just going to retype it because I don't know what's going on right now. So it's going to be your J2, and that's going to be added to our, it's going to be added to our value above it, or, oh my gosh. No, it's our value above it plus our, this value plus, or multiplied by our length, our dz. Okay. Looks good. This is going down little by little. This is going up little by little, which makes sense. F2 looks good. G2 looks good. I2, G2. Okay. Everything seems to be in order. And then our y3 is just going to be equal to 1 minus this cell minus this cell, and that's our length. And then we can just drag these down. Okay, good, they are changing. And then we're just going to go like this. And we're going to scroll down, see if it looks... Oop, we have an error down here for some reason, and I'm not too sure what it is. Okay, I'm going to check these equations that I have at the top and make sure I didn't do anything wrong, and then I'll be back. Okay, I finally found what was wrong after like 15 minutes. There was 3 things that was wrong. So one of the things that I should have picked up on that I didn't was that this value I had negative and it should not be negative. So that was one of the problems. That was probably the easiest one to find. And then this one was probably the hardest one to find. I just didn't have I didn't have parentheses in the denominator, which I should know by now on Excel too, that if you don't have parentheses in the denominator, everything goes wrong. So that was the second problem. And then the third problem, which was probably one of the easier ones to find too, was I just didn't have a period after this. So yeah. Now all my values I think look correct. Make sure there's no errors down here. There's still some. Okay, I'm still gonna have to figure out this problem, I think. But yeah, I'll figure that out and I'll be back. Okay, I'm back again. I did get it. I did figure it out. It wasn't my issue, it was an Excel issue. I don't know what happened, but I just highlighted all these cells and then changed them from general to a number, and then it all worked. But just in like less like numbers, less significant figures, and then I re-changed it back to general, and then it worked. Now it worked. It like stayed without giving me the div0 error. So I don't know how it worked now, but it did work. So yeah. So we got that. So now all we need to do is go into our solver, I believe. Yeah, we just gotta go into data solver, which we've been using in Jonathan Pham's class a lot. So oh wait, we're gonna have to make our objective first. We haven't even made our objective. Never mind. Close. Okay, so we're going to have to do. Oh wait, we need our less values. Sorry, I'm zoning out. It's finals week. Cancel. Okay, so we need these 2 values, I believe. So we're gonna copy these over. Wait, did I copy them? No, I didn't. Okay, copy these over. Bruh. I'm just gonna do them down here. It will work. Actually, no, it's probably not. Is it negative 1.337? Okay, let me get a piece of paper. Hold on. There's one over here. There's a little notepad. Negative. Actually, I'll just be back. Okay. I got our 2 values written down. It's negative 1.33788924 and 1.74474315. So these are our 2 values here, and then in this we need our sum squared of these 2 values here. this is our sum squared, which is going to be what we're going to use in Solver, which I thought we already had. So our objective, let's make sure, okay, yeah, it's the right objective, and then we want the min, and then our changing variable cells, which are our guess cells, are these two values right here, which we did in the earlier part of part 1 on the iPad. And we're gonna hit solve. Objective cell contents must be a formula O. Objective cell must be a formula. That is a formula. Maybe I had the wrong one initially. Okay, I must have just had the wrong cell the first time. Let's see if this worked correctly. I don't think anything changed, did it? Okay, I'll be back again. Okay, after like another half an hour, I found the issue, but what was wrong, which is very obvious, and if you didn't catch on while watching, was I didn't just copy these cells down, or I didn't copy the cells like from the formula. I literally just rewrote the numbers, which won't work because it needs the formulas for it to work. So what I had to do was change this value to the sum squared of the two bottom values instead of just the string or whatever it is. So there, we finally got our values. We have a minimized here, which is what we wanted, here and here minimized, which is what we wanted, and everything down here seems to have worked perfect because it goes exactly to 0.4, and then when you add these up it equals 1, which is what we wanted. So seems to have worked great. The final part for this is explain how scaling and Stefan-Maxwell equations yield good initial guesses for fluxes of acetone methanol. So what we did in the first part on the iPad was scaling the Stefan-Maxwell equation, and we did have good initial guesses of the 1/600 for Solver to work. So that kind of just, the first part kind of just explains how we can not exactly get 100%, but how we can use intuition and unit manipulation to do the values ourselves. So cool.